Hey guys, so our last section of chapter 6 is on properties of kites and trapezoids. First one we're going to talk about is a kite. So a kite is a quadrilateral with exactly two pairs of congruent consecutive sides. So remember, consecutive means next to. We talked a lot with parallelograms about opposite sides being congruent, and then we said, ooh, a rhombus and a square, they've got all four sides congruent, right? Well, in a kite, we've got exactly two pairs of consecutive sides congruent. So when we look at this figure down here, we've got AB is congruent to AD, and we've got BC is congruent to DC. That's our two pairs of congruent consecutive sides. Cool? So if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, perpendicular. So that means then that looking at this picture, we've got this kite, right? That means that AC is perpendicular to BD. Okay, it means that we can draw some right angles in there if we wanted to. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So again, with parallelogram, we said both pairs of opposite sides are congruent, or both pairs of opposite sides, or angles, excuse me, are congruent. Here we're talking about consecutive ones congruent, and then we're talking about exactly one pair of opposite angles congruent. So in this particular picture, angle B is congruent to angle D, but we cannot say that angle A is congruent to angle C. In fact, they are not congruent. Okay? So the two across from each other here are the ones that are congruent. They're in between my two congruent sides. Those are the angles that are going to be congruent to each other. All right. Let's talk about a trapezoid. I'm sure that's another one you guys have heard of, but a quadrilateral. Remember, this whole chapter is on quadrilaterals, right? Four-sided figures. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So we've been talking about parallelograms which have two pairs of opposite sides parallel. Now we're going to talk about, well, what happens when we only have one set of parallel sides. All right, so that's a trapezoid. Each of the parallel sides, those are called bases. All right, and the non-parallel sides are called legs. Two consecutive angles whose common sides are a base are called base angles. Okay, so if we draw a trapezoid over here, okay, so let's call this trapezoid A, B, C, D. Then we know that BC is a base. Oops, I need to put my parallel marks first though. Now I know that it's a trapezoid, sorry. So BC and AC, or AD, excuse me, are the bases. And then we know that BA is a leg and CD is a leg. Now it says that two consecutive angles whose common sides are a base are called base angles. So if we take a look at, for example, angle B and angle C, those would be considered one set of base angles. Okay, and then angle A and angle D would be another set of base angles. So angle A and angle D are base angles. And then angle B and angle C are also base angles. All right, that's important to know. An isosceles trapezoid now, so more specific. Hopefully you guys remember from chapter 4 what isosceles is. An isosceles trapezoid is a trapezoid with congruent legs. Okay, so most of the time it is going to look like this. We've got our parallel sides, and then the legs usually have a tick mark to show us that they are congruent. Cool? All right. moving right along. Now we're going to talk about some theorems for isosceles trapezoids. So if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. All right, so take a look at this trapezoid here. We've got trapezoid ABCD, and BC is parallel to AD. Hopefully you can see those arrows there. If not, maybe draw them in a little bit darker. And then side AB, or segment, excuse me, AB and segment CD are marked congruent. Those are my two congruent legs. So I have an isosceles trapezoid. That means then that each pair of base angles are congruent. So angle B is congruent to angle C because those are my top base angles, right? And then my lower base angles are angle A and angle D, so they are also congruent to each other. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So this is the opposite of what we just said, right? First we started with an isosceles trapezoid, so we said, hey, base angles are congruent. So now we're going backwards. If the base angles are congruent, then we get an isosceles trapezoid. So because angle A is marked congruent to angle D, we know that ABCD is an isosceles trapezoid. Okay. One more cool thing about isosceles trapezoids. A trapezoid is isosceles if and only if its diagonals are congruent. So in this picture, we've got this lovely isosceles trapezoid. It means then that AC, that's one diagonal, is congruent to BD. Okay, so now we're adding even more properties to these crazy quadrilaterals that we're talking about. So let's take a look down here real quick at this graphic organizer. Hopefully this side looks familiar. We did that already, right? Quadrilateral, we said if it's got two pairs of opposite sides parallel, we get a parallelogram. And then we've got our special parallelograms, right? We have a rectangle, we have a rhombus, and if you put a rectangle and a rhombus together, that's when we get a square. Okay, so if we have two pairs of parallel sides, two pairs of opposite sides parallel, that's when we get to a parallelogram. If we've got one pair of parallel sides, that's when we get to a trapezoid. All right, and then sometimes we've got special trapezoids when the legs are congruent. We call that an isosceles trapezoid. Okay. Then we've got quadrilaterals, that have no parallel sides. All right, if they've got no parallel sides, that's what we call a kite. Okay, so hopefully you guys are kind of piecing this all together. I know it's a lot. Bring your graphic organizers to class because we are going to finish filling those out. Okay. Let's do a couple of problems. We are not going to do all of these, I promise. Okay. But I just want to do a couple so that you guys are comfortable and able to do these problems on your own. So we've got this kite, EFGH. The measure of angle FEJ is 25 degrees. So I'm going to put a 25 in there. And the measure of angle FGJ, so FGJ, this one right here, is 57 degrees. And we need to find each measure. So what you have to remember in a kite is we've got those consecutive sides congruent, and those are marked already, right? FG is congruent to GH, FE is congruent to EH, so that's cool. The other thing that's pretty cool about kites is that the diagonals are perpendicular. Okay, so that means we get right angles. So I would, if I were you, draw in that box there so that we can see where the right angles are. Okay, so we are looking for the measure of angle GFJ first. So GFJ, that means we're looking for that angle right there. So I'm going to go over to the side. I'm going to draw us another triangle because we've got F, G, and J. We know that that's a right angle because they're perpendicular. The diagonals are perpendicular. and we were given that this angle was 57 degrees. So hopefully you guys remember your triangle sum. It's got to equal 180. Or if you remember that in a right triangle, the acute angles are complementary, you could do it that way as well. Either way, we get that the measure of angle GFJ is going to be 33 degrees. I would probably just do it by doing 180 minus 90. We get 90, and then subtract that 57, and that's where we get the 33 from. Cool? Now we're looking at the measure of angle JFE. So JFE is this angle right here. So we can do something really similar, right? This angle right here is 90. This one we were given was 25. So we can just do 90 minus 25. And we get 65 degrees for the measure of angle JFE. So I'm going to draw an arrow here. We've got 65 degrees. And we had said that this angle right here is 33 degrees. I'm just trying to keep track of what we've got already. Then we want to find the measure of angle GHE. So GHE is this angle right here, and I'm going to draw two swishes through it just so we can identify which one we're talking about. Well, we have to remember that in a kite, we've got exactly one pair of opposite angles congruent, and it's the angles that are made by my congruent sides. So this angle, GHE, is going to be congruent to angle GFE. So angle GHE is congruent to angle GFE. And we just found out that one part of it is 33, the other part is 65. So we can add those together. We get that that angle is 98 degrees. Okay, so sometimes we have to look at triangles, sometimes we have to look at the kite as a whole. It just kind of depends. So number 2 is really similar. I'm going to let you guys go ahead and work through that one later. All right, let's move on to some trapezoids real quick. So let's do, let's look at number 3, I guess. Number 3 is pretty quick. So we want to find the measure of angle Y. If you look, we're given an isosceles trapezoid because we've got the legs that are marked congruent, which means we know that the base angles are congruent. So this angle is 117 as well, angle Z. And then keep in mind, with the trapezoid, we're given parallel lines. So I can draw that parallel line in. And I've got a transversal. So if I look, I've got same side interior angles, which means I can get the measure of angle Y by just doing 180 minus 117. Okay, so we get 63 degrees for the measure of angle Y. All right, then let's do, how about we do number 6. Let's jump to number 6. Okay. So number 6, we're given JL, so we're given one diagonal is 5Z plus 3, and we're given KM, so the other diagonal is 9Z minus 12. And we know that in a trapezoid, in an isosceles trapezoid, sorry, so if isos trapezoid, then diagonals are congruent. Which means we can set those two pieces equal to each other. So 5Z plus 3 equals 9Z minus 12. All right, and then that means that we can solve for Z. We get 15 equals 4Z, and divide both sides by 4, we get that Z is 3.75. It's okay to get decimals, don't freak out. All right, everybody always freaks out when we get decimals. You'll get a decimal for number 4 as well, but everything else on this page should be a whole number. So I want you guys to give those ones that we skipped a try, so numbers 2, 4, and 5. Give those a shot. We will talk about them when you guys come into class tomorrow, and then we will get you guys ready for your test in a couple of days. Make sure you bring your graphic organizer as well. Okay, I will see you guys later. Bye!